Welcome everybody. This is our seventh session in NEET previous year questions of chapter Moving Charges and Magnetism for class 12th. Before this video, we have made 6 videos in this series and all of those videos are available on our YouTube channel's playlist section. Name of playlist is NEET previous year's questions. We have also started similar series for JEE mains previous year questions. So if some of your friends are preparing for JEE, then you can guide them through that playlist and you can also try yourself with a slightly, we can say, higher level of questions for better practice. And if you find this videos useful, then do press the like button, share it and subscribe to our channel. Also, if you like to support us financially, then you can scan any of these QR codes in front of your screen and donate us with whatever amount you want. With this, let's start today's video and hopefully this is going to be the last video for this chapter. In the previous one, we completed up to 60 and today we will start with 61. So a charge particle, charge Q is moving with the charge, moving in a circle of radius r with uniform speed v. Associated magnetic moment we have to find out. So we have a charge particle which is moving in a circle. So let's suppose this represents its orbit of the charge particle and this is the center for the charge particle and this is radius r. Now, whenever we have to find magnetic moment mu, what we can use? We can directly use the formula for gyromagnetic ratio, and we have like this, that magnetic moment divided by the angular momentum is equal to charge by twice of the mass. This is the formula for gyromagnetic ratio and it is constant for every charge particle with their respective value, their respective ratio of charge and mass, and we can use this here. So mu as it is, angular momentum will be, as we have mass m, velocity v and radius r, so angular momentum will be mv into r is equal to q by 2m. 2m get cancelled and mu is equal to qvr by 2. That is option D for us. Let's move to the next one. A current carrying coil is subjected to uniform magnetic field. The coil will orient so that its plane becomes. Now, here it is asked that coil will orient, and after orientation, how its plane will look like with respect to the direction of the magnetic field. So we know that coil will orient such that the torque acting on the coil should be minimum or the zero. And torque zero is when mb sine theta is equal to 0, or we can say theta is equal to 0. And this theta is between magnetic dipole moment and the magnetic field. So now suppose we have a coil. This is our coil. Now it is mentioned and we have concluded that this is its magnetic dipole moment, because magnetic dipole moment is perpendicular to the plane of the coil. And now we have magnetic field also in the same direction, because theta between coil and magnetic field is 0. So this is magnetic field and this is magnetic dipole moment. These two are in parallel. Only then we have torque 0 and stable condition. In this condition, we can see that plane of the coil, this is the plane of the coil, it is at 90° with respect to the magnetic field. So option D, perpendicular to the magnetic field. Here we are explaining regarding the plane of the coil. Here it is asked about plane, not about the magnetic dipole moment. Magnetic dipole moment is parallel to the magnetic field and plane is perpendicular to the magnetic field. So moving to the next one. If a galvanometer does not show any deflection in the circuit shown, the value of R we have to find out. So it is mentioned that galvanometer is showing no deflection. If it is showing no deflection means there can be two conditions. If it is showing no deflection, let me slide it down and make it slightly thinner. So only two conditions are there when a galvanometer is shown no deflection. Number one, we can say it is the only condition when no current flow through galvanometer. When no current is flowing through galvanometer, only then it will show no deflection. And that can happen in two ways. Number one, that potential across galvanometer is zero, or second case, potential across both terminals of galvanometer is equal. Means either basic condition is that there is no current is flowing between inside the galvanometer, there is no current, only then it will show no deflection. Now no current means either these 2 points are at zero potential or they are at equal potential, and we know for current to flow there needs to be a difference in potential. As there is no difference in potential, there will be no current flowing. Now assume that as both of these batteries are connected to this point, so assume this is our ground, point O. This is our point A and this is point B. Now with respect to O, which is ground, the potential of A is 2 volts because between O and A there is a 2-volt battery. And as there is no current is flowing, so potential at B should also be 2 volt, only then this condition will be satisfied. So from this we can conclude that potential at point B is equal to 2 volts. And as there is no current is flowing, so we can remove galvanometer from the circuit. So our final circuit will look like something this, that we have a 10-volt battery here, 400 ohm resistance, and we have R here, and this circuit is closed. This whole part is removed from the circuit. Why? Because here galvanometer is not working. So if galvanometer is not working means this connection is broken, and if this connection is broken means 2-volt battery is not connected in the circuit. So we have only our circuit reduces to this, and we have 10 volt here. So now current in this circuit I is equal to 10 divided by 400 plus R, and voltage across this resistance. This is point O, this is point B. So we can say VOB or VBO, voltage across this resistance will be current through this resistance times the value of resistance. So current is 10 into 10 divided by 400 plus R multiply R, and this is given to be 2 volts. So cross multiplying we will get 10R is equal to 800 plus 2R, or 8R is equal to 800, or R is equal to 100 ohms. That is option A for us. Moving to the next one. Current sensitivity of a moving coil galvanometer is given, voltage sensitivity is given, we have to find out the resistance. So resistance we know from the Ohm's law that V is equal to IR, or resistance is voltage by the current. This is the maximum voltage that a galvanometer can have, and this is the maximum current that galvanometer can have. So here we have been given sensitivity. Sensitivity means per division how much it can measure. Suppose the galvanometer has n, we can say n divisions. So maximum current it can measure, it will be n times the amount of current which it can measure for unit division. And for unit division it can measure 5 milliampere. Okay, wait a minute. So we need here amount of current per unit division. So we need here current per unit division. Similarly, for the potential, maximum potential that can be measured is the number of divisions into volt per division. But here it is given, we have been given reverse. We require milliampere per division, but it is given division per milliampere. So we have to convert it. So it is given that 5 division can measure 1 milliampere. From this 5 division per milliampere, we can say 5 division can measure 1 milliampere, or we can say from this 1 division will measure 1 by 5 milliampere. Similarly, 20 division can measure 1 volt. 20 division can measure 1 volt, or from this 1 division can measure 1 by 20 volts. So this is the current sensitivity and this is the voltage sensitivity. Division, current per division and volt per division. So let's find out the resistance. Resistance will be N times current measured per unit division. So current measured per unit division is 1 by 5 into 10 raised to power minus 3. Similarly, multiply N by volt measured per division. So volt measured per division is 1 by 20. And from this, what we have, N get cancelled. Oh, sorry, we wrote it in the inverse. It should be volt by current, not the current by potential. So it will be N. First, we need to write potential N into 1 by 20 divided by current N into 1 by 5 into 10 raised to power minus 3. So N get cancelled. We have 1 by 20 into 5 into 10 raised to power 3. So that will be 4,000 by 4, that is 250 ohms. Will be the right answer. Option A will be the right answer. Moving to the next one. In an emitter, 0.02% of the main current passes through the galvanometer. If resistance of the galvanometer is G, resistance of the emitter will be. So we have to find out the resistance of the emitter. For that, we need to calculate the total resistance of the circuit. So let's first draw the diagram that we have a galvanometer here. We have a shunt resistance here, that is R, and resistance of galvanometer is already given to be G. And suppose total current in the circuit is I, and out of this I, 0.2% means 2 by 0.2 by 100 of I passes through galvanometer, and that will be 2 by 1000 I. So current here through galvanometer is 2 by 1000 of I, and remaining goes through the resistance. Now we know that as galvanometer and this resistance both are in parallel, so voltage drop across both of them should be equal. So voltage drop across resistance R will be I minus 2 by 1000 I should be equal to voltage drop across this, and that will be 2 by 1000 I multiply G. So I will get, we can take I and cancel it, and here we will have R into 998 by 1000 is equal to 2 by 1000 into G. So 1000 get cancelled, and R is equal to 2 by 998, that is 1 by 499 of the G. So this is the value of shunt resistance here. And we have been asked that the resistance of the emitter. So we have to find the total resistance of the emitter. So total resistance of the emitter is the parallel combination of R and G. So their parallel combination will give us 1 by R plus 1 by G. This will be the total resistance of the galvanometer. 1 by R will be 499 by G, plus 1 by G as it is. So G 400 plus 1, that is 500. Inversing it, we will get this will be the total resistance of the galvanometer. That is option C for us. Let's move to the next one. A millivolt meter of 25 millivolt range to be converted into a meter of 25 ampere range. The value of ohm necessary shunt will be. So we have to find out what is the value of necessary shunts needed so that it get converted. As it is mentioned that it is a millivolt meter. What does it means? If it is a millivolt meter means it is already working as a voltmeter, so it has already some resistance in series with it. So if this is working as a millivolt meter, it has some resistance in series with it, and we have a galvanometer here, and this is our basic circuit, and its range is given 25 millivolts. So A to B. So we can say VAB is given to be 25 millivolt, and current through this circuit, assuming this is our resistance X. So current through this circuit, or IG, that was initially flowing. So IG is equal to, we can say, total potential divided by the total resistance, and total resistance we assume that is X here. Now it is mentioned, and let me clarify one thing also. This X also include resistance of the galvanometer, because when we convert a galvanometer into a voltmeter, then galvanometer also does have some small resistance, and we add a parallel series resistance to it. So this X is also including the resistance of the galvanometer. We are taking them combined, their combined resistance as X. So now we need to convert into a ammeter. So to convert into ammeter, what we do here, we add a shunt resistance R. We add a shunt resistance R, and now it is mentioned that the current flowing in the circuit that it needs to be measured, that is 25 ampere. So if 25 ampere is flowing in the circuit, then out of 25 ampere only IG can pass through galvanometer, and remaining has to be passed through resistance. So here current will be I minus Ig, and as both of these upper part and lower part, both of these arms are in parallel, so their potential will be equal. So comparing the potentials, we will get value of I is 25, so 25 minus Ig is into R, that is potential difference across resistance R, should be equal to X multiply Ig, that is the potential developed in the upper arm. So here we can write it like 25 into R minus IgR is equal to Xig, and from this what we can do, X into Ig here, X into Ig is 25 into 10 raised to power minus 3. So 25 R minus IgR is equal to 25 into 10 raised to power minus 3. And from this we can say, or we can write that resistance will be 25 into 10 raised to power minus 3 divided by 25 minus Ig. Now we know that when we make a voltmeter with the help of galvanometer by attaching some resistance in series with it, so what happens? Current through it reduces. And now if we see here this expression, here X will be some positive value, as X is the resistance in series, so it will be some higher value, some like 1000 ohm or 2000 ohm, it will be something like that. And on the upper side we have 25 into 10 raised to power minus 3 already, so it is already in negative power. So assuming X to be even to be 1, Here Ig will be 25 into 10 raised to power minus 3, which is very small as compared to 25. So what we can do here, we can neglect Ig as it is going to be very small. So we will be left with 25 into 10 raised to power minus 3 by 25. So value of R comes out to 10 raised to power minus 3 or 0.001 ohm. That is option A for us. Now let's move to the next another question. A galvanometer of resistance G is shunted by a resistance S ohm. To keep the main current on the circuit unchanged, resistance to be put in the series with the galvanometer is. So let's slide down. So we have a galvanometer. A resistance is given G and it is shunted by a resistance S. So this is our circuit now looks like. Now to keep the main current of the circuit unchanged, so it is mentioned that main current needs to be unchanged. Initially and final main current we have to compare. So let's discuss both of the cases. So case 1, before connecting shunt or resistance S. So before connecting shunt, we had our circuit looks like this, and here current is I. So I will be just potential by the resistance of the galvanometer. Now case 2, after connecting shunt. So after connecting shunt, our circuit will look like this, and total resistance of the circuit will be 1 by G plus 1 by S. That will give us Sg by Gs, or inversing it we will get Gs plus Sg. And now current in the circuit I dash, we can say it will be potential by assuming potential is same in both of the cases. So V by Gs into S plus G. So now it is mentioned that keeping current to be unchanged. So current should remain unchanged. So what is the value of this S? So if current is unchanged, then I dash and I are equal. So means V by G is equal to V by Gs into S plus G. And from this it looks like both of are cancelling each other. So I think we made a mistake somewhere. So let me reread the statement. To keep the main current on circuit unchanged, resistance to be put in series. Okay. So we need to put a additional resistance. So in case of second, let me correct it. In case of second, in second case after connecting shunt, we have to add additional resistance R here to keep the current same. So now our total resistance will be Gs Sg plus R. This will be our total resistance. One from their parallel combination and then R in series. So this will be total resistance. So I dash will become, let me rewrite it. So I dash will become Gs Sg plus R. Now we will compare both of these. So V by G is equal to V by Gs S plus G plus R. We get cancelled, and from this we can write that G is equal to Gs Sg plus R, and we have to find the value of R. So R will be G minus Gs by S plus G, Halcyon S plus G. So it will be Gs plus G square minus Gs. Gs get cancelled. So value of R comes out to be G square by S plus G. And that is option C for us. So let's now move to the next question. Galvanometer has a coil of resistance 100 ohm and gives full scale deflection for 30 milliampere current. So full scale deflection, or the maximum current that can pass through galvanometer, is 30 milliampere. So Ig is 30 into 10 raised to power minus 3. If it has to work as a voltmeter, 30 volt range resistance required to be added. So suppose we add a resistance R in series, as it is needs to be converted into a voltmeter. So resistance should be in series. And now we have a galvanometer here, and maximum current, that is 30 into 10 raised to power minus 3. Here point A, this is point B, and potential between A and B is mentioned to be 30 volts. So current in this circuit Ig, that will be equal to 30 volt by the total resistance R plus galvanometer, that is 100. And this value is given to be equal to 30 into 10 raised to power minus 3. So we can write it like 30 divided by 30, 10 raised to power minus 3 is equal to R plus 100. This will give us 1000 is equal to R plus 100, and R comes out to be 900 ohms. Option A will be the right answer here. Moving to the next one. A galvanometer having coil resistance of 60 ohms shows full scale deflection. So first of all, galvanometric resistance is 60 ohm. Full scale deflection current is 1 ampere. It can be converted into ammeter to read current up to 5 ampere. So we need a, we can say, we need to convert into a voltmeter of 5 ampere. As this needs to be converted into ammeter, means the resistance should be in parallel. So the series options already are cancelled or already wrong. So series cancelled and series is cancelled. So we have to solve only for the parallel one. So let's draw the circuit or diagram, that we have a galvanometer here and maximum current through it is 1 ampere, and we add a resistance here, that is suppose R, and as per statement we have to measure 5 ampere current. Out of 5, 1 ampere goes through galvanometer and remaining 4 will goes through the resistance. So as both of these are in parallel, so comparing their potentials, potential across resistance R will be 4R, and potential across galvanometer is 1 into galvanometer resistance, that is 60. So R comes out to be 60 by 4, that is 15 ohm. Option D will be the right answer. Moving to the next one. Galvanometer of resistance 50 ohm connected to a battery of 3 volt with resistance 29550 in series. Full scale deflection of 30 division is obtained by the galvanometer. In order to reduce the deflection to 20 division, resistance in series should be. So here full scale deflection is we can say obtained, means current in the first scenario is equal to the maximum current of the galvanometer or equal to Ig. So here initially what we have a galvanometer with a series resistance of 2950, and we have connected a battery of 3 volts. Here we have connected a battery of 3 volts. So now current in this circuit will be Ig, that is 3 by 2950 plus resistance of the galvanometer, that is 50. So that will be 3 by 3000 or 1 by 1000. This is the Ig, and this current is giving 30 divisions, 30 division deflection. So we can say 30 division deflection is produced by, that is 1 milliampere. 30 division deflection is produced by 1 milliampere, or we can say 1 division deflection will be produced by 1 milliampere by 30. And it is asked that we need to reduce this deflection to 20 division. So 20 division deflection will be produced by 1 by 30 into 20 milliampere or 2 by 3 milliampere. So this is the amount of current when flowing through the galvanometer will produce 20 division deflection. And now we have to calculate that what will be the resistance in the series. So suppose resistance R is in series with galvanometer. We have a battery that is 3 volts and current in this circuit is equal to 2 by 3 milliampere. So current that is 2 by 3 milliampere will be equal to 3, that is the potential, divided by total resistance, that is R, plus G, that is 50. So let's do the remaining calculation. Here from this we will get 2R plus 100 into 10 raised to power minus 3 is equal to 9, and this will be written as 2R plus 100 is equal to 9 by 10 raised to power 3, that is 9000. That for 2R is equal to 8900 and R will be 4450. So option D will be the right answer here. Moving to the next one. Resistance of an emitter is 13 ohm and its scale is graduated from a current up to 100 ampere. After an additional shunt has to be connected to the emitter, it becomes possible to measure up to 750 amperes by this meter. The value of shunt resistance is. So initially this is already working as a emitter, and using that emitter it can measure up to 100 ampere. So let's draw the, we can say, original circuit of this system. So initially what we have here, we have a galvanometer, we have some resistance, suppose S, and this whole circuit is measuring current up to 100 ampere. So total current, that maximum current that can go through this circuit is 100 ampere, and total resistance of this circuit is given to be 13 ohm. So total resistance of this circuit is 13 ohms. Now we have to attach an additional resistance such that, let me rediagram. We have to attach an additional resistance, suppose R, such that now it can measure up to 750 ampere. And now if it needs to measure a 750 amperes in the insider circuit, in this circuit, the maximum current that it can go is again 100 ohm. More than 100 ohm, 100 ampere. If more than 100 ampere goes through this circuit, then this galvanometer will damage. So maximum current that can pass still through the internal part is 100 ampere, and it has a resistance of 13 ohm. So the remaining 650 has to pass through this resistance. Now what we can do, we again compare, as both of these are in parallel, we can compare the potential drop. So potential drop across this resistance R will be 650 into R. It should be equal to the current going through internal resistance, that is 100, and internal resistance combined value is 13 ohm. So from this it will be 150, and R comes out to be that is 100 by 50, that will be 2 ohm. Option A will be the right answer here. Let's move to the next one. A galvanometer acting as a voltmeter will have, so we know that in case of a voltmeter, there is a resistance in series and value of that resistance is high. So high resistance in series with the coil option B will be the right answer. Next one, and this is the last one. A galvanometer of 50 ohm resistance has 25 divisions. A current of 4 into 10 raised to power minus 4 gives a deflection of 1 division. So total current that for full scale deflection will be the number of divisions into current for 1 division. So it is Ig is equal to 25 into 4 into 10 raised to power minus 4, that is 100 into 10 raised to power minus 4 or 10 raised to power minus 2 ampere. This is the current that can flow through galvanometer. To convert this galvanometer to voltmeter, having a range of 25 volt, it should be connected to a resistance. So again, it is voltmeter, so resistance will be connected in series, and we have two options for series, C and D. Let's find out that. Suppose we connect resistance R in series with the galvanometer. Current here is Ig, and potential between point A and B is mentioned to be 25 volts. So value of current Ig from this circuit is equal to 25 potential divided by resistance plus resistance of galvanometer, that is 50, and it is given equal to be to 10 raised to power minus 2 ampere from here. So this will be 2500 is equal to R plus 50, and from this R is equal to 2450 ohms. Option D is the right answer here. So with this, again, this video is complete, and if you like this video and find this content helpful, useful, do press the like button, share it is as much as possible, and subscribe to our channel. Also, if you like to support us financially, then you can scan these QR codes in front of your screen and donate us with whatever amount you want. Any amount of help will be highly appreciated. So with this, again, thanks for watching, and we will meet in next video.